If the moon lining up causes the eclipse, why doesn't this happen every month? Slide, please. Well, the moon does rotate, or does orbit the Earth about once a month. The problem is, its orbit around the Earth is a little bit tilted from the Earth's orbit around the Sun. It's about a 5-degree difference. But that's enough so that sometimes the moon goes a little too high, and its shadow goes over the Earth. Sometimes the moon goes a little too low, and its shadow goes under the Earth. But sometimes we get that perfect alignment. About twice a year we get what are called eclipse seasons, where we can get that sort of alignment. And we're further limited by the fact that the Earth is covered about 70% with water. So it might be possible to see an eclipse about twice a year, but you'd have to get a boat to do so. You'd probably have to go out in the ocean and chase where the eclipse is going to be. Slide, please. So there are 3 general types of eclipse. The most general type is the partial eclipse, the one on the right there, where the moon covers a little bit of the sun, a part of the sun. That's a very nice photo. I did not take it. That is a professionally done photo with someone with more talent than me. Every once in a while, the moon lines up perfectly with the Earth and the Sun, and you can get one of those two on the left, either an annular or a total. If you were here in October, you probably saw the annular eclipse. And if you're here today, at about 1:50 this afternoon, we're going to see a total eclipse. Slide, please. So what kind of eclipse you see kind of depends on where you are. So as far as partial versus total. And in fact, we'll see a partial eclipse for about an hour and a half before totality, and about an hour and a half after totality. And as Patrick said, it's safe to take your eclipse glasses off for that 4 minutes and 11 seconds of totality. You want to keep a close eye on the time. I'm wearing the wrong glasses. You need, where is it? Here we go. One of these. The official NASA eclipse glasses. Same if you're carrying a telescope. If you have a solar filter, you can use it during the partial phase. If you don't have a solar filter, or if you don't know if you have a solar filter, save that for totality. You can get some really nice pictures during totality, but it's not safe any other time. But if we're living in totality, we are kind of living in the shadow of the moon. So the shadow of the moon in this picture is that sort of grayish area, that triangle between the moon and the Earth called the umbra. And if the umbra is long enough that it strikes the Earth's surface, that defines where the totality region is. And as the moon moves and the Earth rotates, that totality region moves. If you are outside that umbra, in the blue sections to either side, it's actually a cone, so that blue region is kind of circular around it. You'll see a partial eclipse. Slide, please. Now, if the moon lines up perfectly with the Earth and the Sun, we'll either get an annular eclipse or a total, and which one of those we get depends on how close the moon is to us. So if you imagine looking at your friend and put your hand out and try to block your view of your friend, if your hand is a little further out, you see a little more of your friend, and that's kind of what we saw during the annular eclipse in October. You're seeing, if you see that picture on the upper right there, that's the moon surrounded by the ring of fire, because the moon is not totally blocking the sun's light. You're getting that ring of fire called an annulus. If you bring your hand closer, you're going to see more of your hand and less of your friend, and that's what's going to happen this afternoon. Eventually the moon blocks out the sun entirely. You don't get that big yellow ball of fire in the sky. Instead, you get a dark region where the moon is, and that very dim light around it, called the solar corona, the upper atmosphere of the sun. That is dim enough that when you're wearing your eclipse glasses at 1:49, and then at 1:50 we get to the total eclipse, it'll go dark, and through your eclipse glasses you won't see anything. That'll be your cue. Slide, please. So if you're in an annular eclipse, what you're seeing is not the umbra, but you're seeing a piece under it because the moon is too far away. You're seeing a piece under it, and it's called the antumbra. So I'll leave you with that. Slide, please. Thank you very much.
Thank you, sir.